Page 2 of the test review. Again, let me know if you have some errors. I'm working quickly and in real time. Derivative of each of these, just some different variety functions. I'm not making the test eternal. I'm just trying to give you some variety in different contexts from things that we've done so far. So f prime of t, 3t squared plus 2, just to give you some different variables and different looks. Number 2 here, we can do with the chain rule, or you can multiply it out at 3x squared plus 4 times 3x squared plus 4, and then go about the power rule. I'm going to do the chain rule because that's something we've learned, and I want to challenge you to utilize that if you can. So this one, f prime of x, what I do is take the derivative of the outside, which is 2, don't touch the inside, because I bring the power out front, and then to the first power. But what happens in that first step is you just leave 3x squared plus 4 alone. Then next to it, you multiply it by the derivative of the inside, the 6x to the first that you're anticipating. Done. That's what I would expect to be a chain rule. If you FOIL it all out, you'll get a nice polynomial, and it would be the same result as if I had multiplied this out and rewrote this derivative in another form, which I can, by the way. This is perfectly good. If you want to go another step, we could look for things to combine. 6 and 2 make 12x, and then I could distribute that 12x, and I could get 12 times 3 is, what is that, 36. That'd be x to the third plus 12 times 4 would be 48x. That's the same thing you get if you did the long haul. And if I made an error in there, do let me know. Now, context problems are they're the same things we've been doing, but they're done in lieu of some kind of context. Now, CVS this is old, 2004 to 2009, but still, man, that is a bang-up business. They're doing a lot of business. What I want to do is approximate the average rate of change, slope of a secant, for 2005 to 2008. So when you look at the way the units are done, 4 is 2004. So what I'm going to do is t equals 5 to t equals 8. I'm going to find the secant line slope. So what that means is I'm not doing a derivative. So average rate of change is not the derivative. Derivative is for instantaneous rate of change, or tangent line slope. So not the derivative on this one. This is all algebra here, just inputting values. Keep that in mind. All right, so what I'm going to do is take this sales function, and I'm going to put 8 in, and minus the sales with 5 plugged in, because those are the appropriate years, over the 8 minus 5. And we're going to get that slope of the secant line that goes with that. I don't have a calculator sitting in front of me, so I'm going to leave that one for a minute and say, you go ahead and plug those in there and tell me what you get. But that's the result. And if I have a minute here, what I'll do is I'll publish the PDF of this key, and you can look for the numerical answers there. But that's the process. You're just getting basically an output, whatever this curve happens to look like. You're putting in 2005, 2008, and what we're calculating is the rise and the run, and that's just an algebraic process. Okay, so the next piece, instantaneous rate of change, is when we do take the derivative, and on this derivative, it's nothing fancy. It's just you take s prime, and it's multiply the 3 out front that you see in the exponent, so it becomes, you just triple what you have inside there. And so if I do a quick little calculation here, get a calculator. I have a basic calculator handy, nothing graphing wise, and let's see what I got. Second quick clear. So we have 3 times 1.3241, you get this negative 3.9723, and that's t to the second. And then you have 26 times 0.562 times 2, and you get 53.124, and that's it. And you just want to make sure you get the right exponents, and you're good to go. And then the last one is nice and simple because it's just derivative of 155.81t is just 155.81. Done. There's your derivative. Now it says find the instantaneous rates of change for those particular years. And so, hey, wait, I do have the graph of this one included on there. Oh, I love when I think ahead like that. I was thinking I didn't want you guys to be dependent on a calculator, but you in fact can handle this. That's good. what we're going to do next is you're going to plug those values into this derivative function. So for 2005, we're going to put 5, in for t in each case and calculate it. When we're doing 2008, we're going to put 8 in for t in each of these cases and get those results. And so what I'll do is, again, later I'll calculate those and put those in for you. But s prime of 5, I'll get you a number for that. It's for plugging it in. S prime of 8, and I get you a slope for that. What happens is you go to the curve, and we're going to graph all these things and compare their results. And so I'm going to plot at s prime of 5. Oops, back it up here. Means I'm going to go, here's the function of s that I've got graphed up here for, but if I go to 5 and I do an instantaneous rate of change to that, it is going to be, it's probably not going to look like that, but something like that. And you go to 8, so 5, 6, 7, 8, and I go to about right there. The instantaneous rate of change there looks like it's a little bit different, maybe a little bit steeper. And then the average rate of change between the two, that part A question that I had, was me connecting those two with a secant line, so that's altogether different slope than those previous two. So the comparison is to look at their size comparison, one steeper than the other. It also tells you a little bit about it started on the uphill, it's about to increase in slope starting from here, and if you notice on the top end as you get to 2008, it's starting to decrease in slope. So notice those trends, and on average over that period of time, the secant is the average slope on that particular interval. It's not the individual slopes at any given time, but just on average what the slope is for that period or that interval. Okay, so those are things that when you see my write-up of the comparison, you can kind of see where that comes from. All right, that's page 2. I'm going to move on to page 3 and get you another recording.